Far beyond the last familiar planet, in the cold dark between the stars, something is pulling the outer solar system in a direction nobody has yet explained. Welcome to Science Explained Daily, where tonight we drift through a whole collection of quiet mysteries that have never quite been answered. Find somewhere comfortable, let your breathing slow, and let the voice carry you gently out toward the edge of everything. Many billions of kilometers from where we began tonight, past the orbit of Neptune, the solar system does not simply end. There is a region out there, dim and slow and very cold, where small frozen worlds drift in long unhurried arcs around the distant sun. The sun, seen from that distance, is only the brightest of the stars, a pale steady point of light in an otherwise unbroken field. It is a place of extraordinary stillness, where a single orbit around the distant sun takes hundreds of years to complete. Astronomers have mapped dozens of these small frozen worlds, each one tracing its own patient path through the silence. And yet something about the way they move has never fully made sense. Their orbits are tilted, and they cluster together in a way that the known planets alone cannot account for. The pattern is quiet but persistent, like a signature left by something enormous that nobody has ever seen. Some of the most careful observers of the sky began to notice this clustering nearly a generation ago. They watched the data slowly accumulate, checking it again and again, uncertain whether to trust what they were seeing. The objects they were studying, Sedna and its distant companions, follow paths so elongated they spend most of their lives in a place no instrument had ever reached. Sedna itself was found in the early years of this century, a small reddish world drifting at a distance that took the mind some effort to hold. At its closest, Sedna is still so far from the sun that the warmth you feel on a winter morning would be unimaginably remote. And at its farthest, it drifts out toward a region so distant that light from the sun takes more than a day to reach it. What Sedna is doing so far out, and why its path is shaped the way it is, has never been satisfactorily explained. One possibility, considered carefully and never quite dismissed, is that a large unseen planet is slowly shepherding these outer worlds. This proposed world, sometimes called Planet 9, would be perhaps 10 times the mass of the Earth, sitting far beyond Neptune in perpetual shadow. It has never been observed directly, and astronomers continue to disagree about whether it is truly there. The telescopes that could find it, if it exists, are powerful enough that even a faint slow-moving dot would eventually appear. Surveys of the sky are ongoing, patient sweeps conducted year after year, covering more and more of the outer darkness. And each year the silence continues, which is itself a kind of answer, though not the one anyone was hoping to find. There are other explanations too, quieter ones, that do not require any hidden world at all. Perhaps the clustering of these orbits is simply the remnant of a very early time, when the solar system was still finding its shape. Or perhaps a passing star, long ago and long departed, nudged these distant travelers into the paths they now follow. That star, if it came, would have left no forwarding address, only this slow and silent rearrangement of the sky's most distant furniture. None of these possibilities has been ruled out, and none has been confirmed, and the outer solar system goes on turning in its own unhurried way. Out beyond Neptune the sky is very clear, and very full of stars, and the objects drifting there do so without any awareness that they are mysterious. They follow their long ellipses with perfect indifference, tracing arcs that will not complete within any human lifetime. Perhaps in time a survey will catch a glint of something large and cold moving slowly against the fixed stars. Or perhaps the answer is something quieter and stranger, a shape in the data that points not to a planet but to something we have not yet imagined. For now the edge of everything remains exactly that, a boundary we can measure but not quite cross, full of slow cold objects moving through a silence that has lasted since before the Earth had oceans. Let us drift now, back through the quiet centuries, back past the age of telescopes and steam, to the cold edge of the inner solar system. Somewhere in the vast belt of stone and ice that circles between Mars and Jupiter, a small world turned slowly in the silence. It is called Ceres, and for a long time it was known only as a faint point of light that wandered among the fixed stars. It was discovered on the first day of the 19th century, by an Italian astronomer who had been searching the sky for something he barely knew he was looking for. For nearly 200 years, Ceres remained a mystery wrapped in distance, too small and too far for any instrument to resolve its surface. Then, slowly, the age of spacecraft arrived, and a small probe named Dawn began its long journey outward through the solar system. It traveled for years, crossing the vast silence between planets, carried on ion engines that burned with a faint blue flame too gentle to feel. As Dawn drew closer to Ceres, the pale dot in its cameras slowly began to grow, resolving into a world with craters and plains and rounded hills. And then, in the early months of 2015, the scientists watching the incoming images noticed something that made them pause. There, on the gray and ancient surface of this small world, there were bright spots, intensely white, sitting inside a wide crater in the northern hemisphere. They were brighter than anything else on the surface by far, catching and reflecting the distant light of the sun like polished salt or fresh snow. The crater that held them was given the name Iapetus, and it measured roughly 90 kilometers across, wide enough to hold a small country within its walls. The crater itself was ancient, perhaps 20 million years old, shaped by an impact so long ago that the earliest human ancestors had not yet appeared on Earth. But the bright spots inside it appeared younger, somehow fresher, as though something had been placed there, or had risen there, far more recently. The largest and brightest cluster sits at the very center of the crater, on top of a low dome of material that rises gently from the floor. This central bright spot is called Cerealia Facula, and it is surrounded by a soft haze on some of Dawn's images, a thin mist that seems to breathe. Around it, scattered across the floor of the crater, a second cluster of brighter patches spreads in a quieter, more irregular pattern. These are called the Vinalia Faculae, and they gleam softly in the low sunlight, like patches of ice left behind by a tide that has long since gone. When scientists measured what these spots were made of, they found salt, sodium carbonate in particular, in concentrations found nowhere else in the known solar system. The kind of salt that forms when salty water evaporates, leaving its minerals behind as a white crust on the surface of whatever it once touched. Which meant, quietly and slowly, the question began to form: if salt requires water, then where had the water come from, here on this small frozen world? Beneath the surface of Ceres, there may be a reservoir, a body of salty water kept liquid by the gentle warmth that still lingers inside the small world. This brine, warmer and salter than the sea, would be too heavy to stay below, and so it rises, slowly, through cracks in the ancient rock. When it reaches the surface and meets the near vacuum of space, the water in it turns immediately to vapor, leaving the salt behind in white crystalline layers. This process is still happening today, slowly and quietly, which is why the bright spots seem somehow newer than the crater that contains them. Dawn detected water vapor above the crater, a thin, fleeting exhalation rising from the bright spots and dispersing into the cold space around Ceres. And so Ceres exhales, very slowly, releasing a whisper of moisture into the void, the way a sleeping figure breathes on a cold winter night. What remains unexplained is the timing, the fact that the impact that formed Iapetus happened long ago, yet the bright material looks so very fresh. Something must have disturbed the interior of Ceres relatively recently, reopening the channels through which the brine could find its way to the surface. But what that disturbance was, and what it says about what still stirs quietly in the heart of this small world, nobody yet fully understands. There are other bright spots on Ceres too, smaller ones scattered across its surface, more than 300 in total, each one a quiet mark left by rising water. They are found in craters, mostly, as if the impacts themselves crack the crust just deeply enough to let the interior breathe outward. Ceres, it seems, is not as still and finished as it appears from a distance, but is something stranger, a world that is slowly, gently seeping. And somewhere beneath that gray and cratered surface, beneath the cold and the silence, the water waits, very patient, neither fully still nor fully gone. From the stone and the soil, attention lifts now gently upward, into the quiet dark of open space. Far out beyond the familiar planets, a small rocky world drifts slowly along its ancient path around the sun. Its name is Bennu, and it has traveled this same quiet ellipse for billions of years without interruption. It is not large, a rough sphere of rubble and dust, about half a kilometer across, tumbling slowly end over end. When a spacecraft finally arrived to study it, Bennu appeared calm at first, cold and still and unremarkable in the silence. Then the instruments noticed something that nobody had expected, something small and strange rising from the surface. Tiny flecks of material were drifting upward from the asteroid, lifting off the rock and floating into the surrounding space. Some of these particles rose gently and then fell back down again, like slow-motion sparks drifting in still air. Others escaped entirely, drifting away into the surrounding darkness without any clear reason to explain why. Scientists had watched many asteroids before, and none had ever behaved quite like this. The events came without warning, appearing at odd moments scattered across many weeks of close observation. Sometimes only a few grains lifted away, at other times, dozens of small fragments rose together in a gentle drifting cloud. The largest particles were only about a centimeter across, small enough to hold between two fingers, yet they moved with quiet purpose. Researchers studied the data carefully and proposed several possibilities, though none of them fully accounted for what was seen. Perhaps small meteorite impacts were dislodging surface grains, tiny collisions too brief for any instrument to directly catch. Or perhaps the asteroid's surface was cracking slowly as it moved between warmth and cold, the rock contracting and releasing tiny pieces. Some thought it might be water ice hiding just beneath the surface, evaporating gently and carrying particles upward as it escaped. But Bennu showed no strong signs of ice, and the timings of the ejections did not match the patterns that sublimation would predict. The ejections happened in daylight and in shadow, near the poles and near the equator, following no tidy rule that science could write down. Each event remained its own small mystery, quiet and self-contained, leaving only the faint trail of floating grains as evidence. There is something quietly remarkable about watching a world so old and still capable of surprising those who came to understand it. Bennu has been circling the sun since before Earth had oceans, carrying within it material from the earliest days of the solar system. What moves within it now, what stirs it still after all that time, remains something that observation alone could not fully resolve. The spacecraft watched in silence, cameras open, recording each small plume of rising material with patient and unhurried attention. And with each new event, the picture grew richer but no simpler, the question remaining open and softly unanswered. Perhaps it is enough to simply know that even a stone this old, drifting this far from home, still holds its own slow secrets. The ejected particles continued their slow journeys outward, some falling back to the surface after hours or even days aloft. In the very low gravity of Bennu, even a pebble released gently could take a long, wandering path before coming to rest again. Some grains found their way into orbit around the asteroid itself, becoming tiny temporary moons circling a world barely large enough to hold them. It is a gentle thing to imagine, that small loop of drifting material turning quietly around a rock in the silence of space. In time, even those tiny orbiting grains would drift away or settle back, absorbed again into the surface that released them. And Bennu would continue its long ellipse around the sun, patient and unhurried, carrying its quiet mystery forward into the years. Whatever stirs within it still, whatever slow process lifts those small grains into space, it has been doing so for a very long time. And somewhere in the stillness of that thought, it is easy to let the mind grow quiet, and simply drift alongside it. And now, quietly, we turn our thoughts toward Saturn, that pale ringed world drifting alone in the cold outer dark. Saturn hangs in the solar system the way a lantern hangs in a very large room, distant and self-contained. For most of its long year, which lasts nearly 30 of our own, Saturn's atmosphere is calm, layered, and still. The cloud belts wrap around the planet in slow parallel rivers, moving together, barely changing. And then, once every 30 years or so, something enormous stirs beneath those quiet clouds. A white spot appears, small at first, a pale smudge against the caramel-colored atmosphere. Astronomers on Earth, watching through their telescopes, notice it and quietly write it down. Within days the white patch has grown, spreading east and west along the equatorial belt like a slow spill of cloud. The storms are made of ammonia ice crystals lifted upward from deep warm layers far below, rising until they freeze. The white is very bright, bright enough that even a modest backyard telescope can find it on a clear night. The first recorded great white spot appeared in 1876, noticed by Asaph Hall, who was also the man who found the moons of Mars. He watched it move across the disk of Saturn night after night, a bright knot carried by the equatorial winds. In 1933 another white spot emerged, this one so vivid that amateur astronomers across Europe reported it the same week. It stretched and elongated until a bright band of white encircled nearly the entire planet. The storms come in roughly 30-year intervals, spaced like chapters in Saturn's own unhurried calendar. Scientists have noted the timing but still cannot say with certainty what sets the clock ticking each time. Something deep inside the planet, in the warm hydrogen layers far below the visible clouds, must build slowly and release. In 1990 the Hubble Space Telescope, newly in orbit, turned its eye toward Saturn and found another great white spot in full bloom. The 1990 storm was captured in extraordinary detail, a churning white mass spreading across the northern equatorial belt. Winds inside the storm reached speeds that dwarf anything a hurricane on Earth could produce. Yet from far away, the great white spot still looks soft and almost gentle, a pale smear on a pale world. In 2010 came the largest great white spot yet recorded, and the Cassini spacecraft was already there, waiting. The 2010 storm began in the northern hemisphere in December, a single bright head of cloud punching upward through the calm layers. Over the following weeks it grew and stretched until the storm's tail had wrapped entirely around the planet. The head of the storm eventually caught up with its own tail, and the two collided in a slow, swirling merger. After that collision the storm began to settle, the white clouds thinning and spreading into softer, quieter patterns. Cassini's instruments listened to the storm in radio waves and found it crackling with lightning on a planetary scale. The lightning discharges were millions of times stronger than anything recorded in a terrestrial thunderstorm. And yet the storm made no sound that would reach any ear, occurring in the deep silence of space. What remains after the storms is a subtly changed atmosphere, temperatures warmer, chemistry altered, before the cloud bands slowly smooth again. The planet waits then, as it has always waited, through decades of stillness until the deep interior builds its pressure once more. No one has yet explained precisely why the storms recur with such regularity, or what finally tips the balance each time. Perhaps the answer lies somewhere in those unreachable deep layers, warm hydrogen pressing slowly upward in the long dark. For now Saturn keeps its rhythm quietly, far away, carrying its great white storms like a secret it shares only once a generation. And now, from whatever still place the last story left you, let your thoughts rise gently upward, away from stone and sea, into the cold and quiet of open space. Far out in the solar system, past the rust-colored storms of Jupiter, there drifts a moon unlike almost anything else we have ever found. Its name is Ganymede, and it is the largest moon in our entire solar system, larger even than the planet Mercury. It is a world of ancient ice and grooved rock, its surface worn and quiet, touched only by faint sunlight that travels 500 million miles to reach it. For a long time, Ganymede seemed simply still, a frozen world slowly orbiting its enormous parent planet, unhurried and unremarkable in its silence. But something moves on Ganymede, something that scientists quietly call the most surprising discovery about this distant, icy place. There are auroras on Ganymede, ribbons of soft light that shimmer at the edges of its polar regions, shifting and breathing in a kind of slow, wordless dance. They glow in ultraviolet light, a color our eyes cannot see, but which instruments have quietly traced across the moon's face for years. The auroras exist because Ganymede carries something rare and unexpected, its very own magnetic field, buried deep within its iron core. No other moon in the solar system is known to generate its own magnetic field, and scientists still hold quiet wonder at why Ganymede alone does this. That magnetic field reaches outward from the surface, forming an invisible bubble that catches charged particles streaming from Jupiter and the Sun. And where those particles are guided down toward the poles, they ignite the gas in the thin atmosphere above, and the aurora begins to glow. The process is the same gentle physics that paints our own night skies on Earth with green and violet, carried here across 500 million miles. But on Ganymede, it happens inside a much larger and stranger neighborhood, surrounded by the immense, churning magnetic field of Jupiter itself. Jupiter's magnetic field is the largest structure in the solar system, stretching millions of miles in every direction, and Ganymede sits nestled within it. The auroras on Ganymede are shaped by both magnetic fields at once, their own and Jupiter's, tugging and pressing against each other in slow, invisible conversation. When Jupiter's magnetic field shifts and pulses, the auroras on Ganymede respond, rocking gently north and south in rhythm with those distant changes. Scientists watching through the Hubble Space Telescope noticed this rocking motion, a soft oscillation of just a few degrees, and recognized something remarkable hidden within it. If Ganymede were frozen solid all the way through, the auroras would rock by a certain amount, but the measurements were smaller than expected, quieter. The most careful explanation is one that still fills researchers with a kind of soft amazement: a vast saltwater ocean, hidden miles beneath the ice. Saltwater conducts electricity, and a deep ocean of it could create its own dampening effect on the magnetic field, gently muffling the auroras rocking. So the dancing auroras above may be whispering something about a hidden sea below, a world of water sealed away under miles of ancient ice. Nobody has ever reached that ocean, and no instrument has yet touched its surface, so it remains entirely in the realm of inference and quiet possibility. The auroras themselves are beautiful without needing to mean anything, two soft bands of light curving across the poles of a cold and distant moon. They shift and breathe across the surface, moving with a rhythm that is older than anything we have built, older than almost any human thought. In the thin atmosphere above the ice, the glow is almost nothing, just a trace of oxygen and hydrogen lit by invisible particles, a whisper of light. That atmosphere is so thin you could not breathe it, but it holds the aurora like a frame, a delicate shell around the whole silent world. And so Ganymede turns, slowly, taking just over 7 Earth days to complete one orbit around Jupiter, its auroras turning with it. The same face of Ganymede always points toward Jupiter, locked in a gravitational embrace, never turning away, the aurora steady on its poles. Somewhere in the dark beneath the ice, if there is an ocean, it has been sealed away for perhaps 4 billion years, undisturbed and perfectly still. Whatever is in that water, if anything, has never seen a sky, has never felt a current from wind, has existed only in perfect and total quiet. And above all of that, the auroras move, those soft and ancient ribbons of light, dancing for no one, watched only by the stars and by instruments far away. There is no explanation that fully closes the question of why this one moon, alone among all moons, generates the field that makes this light possible. And perhaps it is enough, for now, simply to know that it is there, that somewhere far away a moon is quietly dancing with its own soft light. The hour has drifted a little later now, and somewhere far beyond the warmth of Earth, the night of space deepens without end. Jupiter hangs there, enormous and unhurried, wrapped in slow bands of amber and cream that circle its vast equator. Most who gaze at Jupiter see only those broad swirling clouds, but closer in, something far quieter waits. Wrapped around the planet like a barely there whisper is a ring system so thin and pale it was almost never found. These are Jupiter's rings, and they are nothing like the grand ice-bright rings that circle Saturn far away. Where Saturn's rings shine white and bold, Jupiter's drift almost invisibly, a faint gauze across the black. The rings were not discovered by patient human eyes at a telescope but revealed almost by accident in 1979. The Voyager 1 spacecraft was carrying its cameras past Jupiter when scientists asked it to look back toward the planet's edge. In that single long exposure, a faint arc of scattered light appeared where no one had expected anything at all. It was so delicate that the image had to be studied carefully before anyone would believe what it was showing. Jupiter's ring system is made not of ice or large rock but of tiny grains of dust, each one barely larger than smoke. These grains are so small and so spread apart that the ring barely interrupts the starlight passing through it. The ring system has several parts, each one progressively wider and fainter as it reaches further from the planet. Closest to Jupiter is the halo ring, a broad puffed cloud of dust that glows faintest of all in forward scattered light. Beyond that lies the main ring, narrow and bright by comparison, perhaps only a few kilometers thick but stretching outward for thousands. And beyond the main ring the gossamer rings begin, two vast faint sheets that drift outward to extraordinary distances. The name gossamer was chosen well, for these outer rings are barely present at all, more suggestion than substance. They are fed by two small moons, Amalthea and Thebe, whose surfaces are slowly worn away by the steady rain of micrometeorites. Each tiny impact on those moons sends up a cloud of dust, and some of that dust escapes into the ring. In this way the rings are not ancient remnants frozen in place but constantly renewed, always slowly dying and always slowly being born. The dust drifts slowly inward under the pull of Jupiter's enormous gravity, spiraling down over thousands of years. Without the moons continuously shedding new material, the rings would fade entirely and vanish without trace. What remains is always changing, always thin, a quiet balance between creation and dissolution out in the cold of space. Scientists have wondered for years whether the rings were always this thin or whether they were once far more substantial. There is no certain answer, and perhaps there never will be, for the rings keep no record of their own past. The dust simply drifts, holding its orbit, indifferent to questions of origin or age or meaning. Seen from certain angles, in the right kind of light, the rings glow more brightly, almost warm, almost visible. This forward scattering is how Voyager first revealed them, sunlight bending around each tiny grain and amplifying the whole faint veil. From Earth, even with the largest telescopes, the rings are nearly impossible to see, hidden behind the planet's own overwhelming brightness. Only when spacecraft crossed to the far side and looked back, with the sun behind them, did the rings finally appear. There is something quietly remarkable about a ring system that can only be truly seen from inside the solar system, looking back. The gossamer rings stretch out to the orbits of Amalthea and Thebe, following those small moons in their patient circles. Beyond those orbits, the dust thins to nothing, and the ring simply ends, giving way to ordinary empty space. And so Jupiter's thin gossamer rings continue drifting there tonight, as they have for a very long time, quiet and nearly invisible, needing nothing from us at all. A slow wind moves across the outer reaches of the solar system, carrying nothing but cold and silence and the faint memory of the sun. Somewhere in that quiet, a small world drifts in an endless orbit, painted in colors unlike anything else we have ever found. This is Io, the innermost of Jupiter's great moons, a place so alive with fire that its entire surface is always slowly changing. The colors that stretch across it are warm and strange, deep reds and vivid oranges, soft yellows and patches of pale white, like a cooling pie left on a windowsill. Scientists, when they first saw these images returned by Voyager, quietly reached for the closest comparison they could find, and someone said it looks like a pizza. The name stayed, somehow, because it was true, a warm, improbable, oddly comforting truth about a moon millions of kilometers from home. What makes Io look this way is heat, not from the sun, which is very far and very faint at this distance, but from deep inside the moon itself. Jupiter is enormous, and its gravity pulls at Io constantly, and the moons nearby pull back in the other direction, and Io is caught between them. This tug, steady and unrelenting across billions of years, squeezes Io like a hand gently pressing a piece of fruit, and the friction deep inside becomes heat. That heat has nowhere to go but up, and so it rises through the rock, and Io becomes the most volcanically active place in all the known solar system. There are hundreds of volcanoes on this small world, some gently breathing steam and sulfur into space, others erupting in slow sustained fountains for years at a time. The sulfur they release falls back to the surface and freezes there, slowly building up the layers of color that give Io its extraordinary painted look. Red comes from sulfur that is older, exposed longer, perhaps touched by radiation from Jupiter's powerful magnetic field sweeping past in great invisible waves. Yellow and white are fresher deposits, laid down recently by eruptions still quietly at work somewhere just below where we can see. Loki Patera sits near the equator, a vast dark lake of churning lava larger than the state of Maryland, quietly and steadily glowing. It has been overturning itself, the dark crust of cooling lava rolling slowly inward like the skin of a slow wave, for decades without pause. Pele is another, older and grander, an enormous caldera surrounded by a ring of deep red sulfur that spreads for hundreds of kilometers in every direction. That red ring is what Pele breathes out, sulfur carried high into space by its eruptions and then falling gently back, settling like snow around the vent. When spacecraft passed by, they could see those plumes rising silently above the limb of Io, vast and transparent against the black of space. One plume, called Tvashtar, stretched nearly 500 kilometers high, a slow fountain that hung in space like a veil of dust catching far-off light. From the surface, if one could stand there in the thin cold, Jupiter would fill a large portion of the sky, enormous and banded and endlessly rotating. The light that reaches Io from Jupiter is soft and reflected, a pale secondary glow that falls across the sulfur plains without much warmth. In the long silences between eruptions, those plains would be still, very still, an orange quiet stretching in every direction under the distant sun. Io has almost no atmosphere to hold the heat or blur the stars, so above those plains the sky is black even in full daylight, and the stars do not twinkle. The mountains of Io are not volcanic in the usual way, they are lifted by compression, the crust being pushed together so relentlessly that rock rises in tall ridges. Some of those mountains are as tall as anything on Earth, rising quietly and enormously from flat sulfurous plains that surround them on every side. Beneath all of this, beneath the color and the fire and the mountains, there may be a global ocean of liquid rock slowly turning inside Io. That thought sits quietly, somewhere between the known and the unknown, a deep warm sea of stone that no instrument has yet confirmed, and none has disproved. Everything on Io's surface is temporary, the colors will shift, the calderas will fill or drain, the plains will be resurfaced by eruption, it never stays. Scientists comparing images taken years apart have found familiar features gone, new ones in their place, the whole surface rewritten slowly by the fires beneath. What this means, gently considered, is that Io is always in the process of becoming something else, never quite finished, never quite the same twice. There is something restful in that thought, that a world so far away is simply, slowly, going about its ancient work, without urgency, without end. The pizza-colored surface rolls on past the horizon in every direction, layered and warm-toned and endlessly repainted by the quiet inner fires. And far away, the sun continues its slow burn, and Jupiter turns, and Io moves through its circle, painting and repainting itself in the stillness of the outer dark. Far across the solar system, many millions of miles from wherever our thoughts have been resting, there drifts a strange and ancient traveler. Its name is Phaethon, a small rocky body that circles the Sun in a long, looping path unlike most of its quiet neighbors in the asteroid belt. Astronomers noticed early on that something about Phaethon was quietly unusual, gently different from the gray and rust-toned rocks surrounding it. While most asteroids wear dusty shades of gray or brown, Phaethon reflects sunlight in a way that gives it a faint but unmistakable bluish hue. That quiet blue color has puzzled people gently for decades, sitting at the edge of understanding like a word almost remembered. Phaethon belongs to a rare family called B-type asteroids, a small and somewhat mysterious group that sits quietly at the blue end of the spectrum. The blue tint suggests certain minerals on its surface, perhaps hydrated silicates or carbon compounds that have been gently cooked by countless ages near the Sun. What makes this especially interesting is that Phaethon swings closer to the Sun than almost any other named asteroid, grazing the inner edge of Mercury's orbit. At its closest approach, the surface heats to temperatures that would soften lead, and yet the blue color quietly persists. Most minerals that start with any blue tint would be expected to redden and darken under such relentless heat, slowly changing as time passes. Yet Phaethon holds its blue coloring, quietly resisting the reddening process that space weathering normally brings to rocky bodies over time. Some researchers have suggested that the intense heat near the Sun actually refreshes the surface, baking away the reddened dust and revealing fresher blue material beneath. It is a gentle kind of renewal, the Sun itself perhaps keeping Phaethon looking younger and stranger than its surroundings. There is also something else about Phaethon that sets it quietly apart. It leaves behind a trail of debris that, each year, rains down on Earth as a meteor shower. The Geminids, as this shower is called, are one of the most reliable and generous of all the annual meteor displays, appearing each December. But here the mystery quietly deepens. Most meteor showers are left by comets, whose ice vaporizes and releases dust, but Phaethon is a rocky asteroid with almost no ice. It behaves, in some quiet and puzzling way, like both a comet and an asteroid at once, which is why it has been gently named a rock comet. When Phaethon swings close to the Sun, instruments have detected a faint brightening and a tiny tail of dust, almost like a shy echo of a comet's display. That faint tail is far too small to produce the Geminid shower on its own, leaving scientists to wonder quietly how the debris trail ever formed. Perhaps long ago there was a collision, or a sudden outburst, something that released a vast cloud of material that has since spread quietly around its orbit. Whatever happened, those ancient fragments now travel in a long river around the Sun, and Earth passes through that river every December without fail. And the blue color of Phaethon is woven into this whole quiet story, because the Geminid meteors themselves carry a chemical signature that matches their parents' unusual tint. Scientists studying the light from incoming Geminid meteors have found traces of the same sodium-poor, blue-tinted composition that Phaethon itself displays. Sodium evaporates quickly at high temperatures, and some believe that Phaethon's repeated close passes to the Sun have slowly baked it away, leaving the blue minerals behind. So the blue color may be a kind of scar, a quiet record of every journey Phaethon has made toward the heat of the Sun across billions of years. In 2024, Japan launched a spacecraft called Destiny Plus on a long and gentle journey to visit Phaethon and study it from close range. That mission is still traveling slowly through the dark, and its arrival years from now will be a quiet moment of finally seeing what has only been glimpsed from afar. Until then, Phaethon continues its patient ellipse, tilting toward the Sun and then pulling back into the cooler reaches of the inner solar system. Each loop takes about 1.5 years, and with every loop the surface is heated and cooled, perhaps flaking and refreshing its peculiar blue skin once more. There is something softly remarkable about a rock this old, older than Earth itself, still carrying a color that science has not yet fully explained. Some colors in nature simply persist, surviving eons of heat and cold and silence, and asking no permission to remain. And so Phaethon drifts on through the quiet dark, its surface holding that faint blue tone like a stone that has simply forgotten how to change. Somewhere out there tonight, it is moving, slowly, steadily, a small blue world with no one watching, circling the same star that keeps us warm. And that small blue fact, drifting in silence through the solar system, is enough to carry the mind gently outward and let it rest among the stars. Somewhere far out beyond the last familiar planets, there is a silence so complete that no wind has ever carried a sound across it. Out there, drifting slowly at the very edge of the solar system, lies a small and frozen world called Pluto. It is smaller than our moon, and yet it carries mountains taller than many on Earth, rising in great pale ridges against a sky of cold stars. When a spacecraft finally reached Pluto after 9 years of quiet travel, the images it sent back were almost impossible to believe. The peaks of Pluto's highest mountains were white, dusted with something pale and fine, like the first thin snow of a winter morning. But this was not water snow, not anything that would feel familiar to a hand reaching out to touch it. What had settled on those mountains was methane, a gas here on Earth, frozen into delicate crystals in the cold of a world 4.5 billion miles away. The mountains themselves are made of water ice, hard as granite in temperatures 300 degrees below freezing. And rising above those frozen slopes, the methane drifts and falls in ways that scientists are still quietly trying to understand. Pluto has a thin atmosphere, barely there, a faint blue veil that wraps the world in layers of haze. As Pluto moves in its long slow orbit, that atmosphere breathes in and out, freezing and sublimating with the changing of its distant seasons. One Plutonian year lasts 248 of our years, so its seasons change on timescales almost too long to imagine. When scientists first saw the white-capped peaks, they thought of Earth's own mountains, where cold air rises and moisture falls as snow on the summits. On Earth, the air cools as it climbs, and the cold brings the snow to the peaks rather than the valleys. But Pluto is stranger than that, and the methane on its peaks follows a different kind of logic entirely. On Pluto, the atmosphere is actually warmer higher up, while the surface itself stays coldest of all. The methane gas in the lower atmosphere condenses more easily onto the cold mountain peaks, settling there slowly like a breath fogging a cold window. So the frost gathers where the air is coldest, and the coldest air sits against the mountains, not above them. It is a snowfall unlike any other, settling not from clouds but from the thin ghost of an atmosphere pressing gently against cold stone. There are no clouds on Pluto, no gray skies gathering before a storm, only that pale haze hanging silently above everything. The great heart-shaped plain of Pluto, called Tombo Regio, lies smooth and white just beside these mountains, a frozen sea of nitrogen ice. Nitrogen ice flows there in slow glaciers, barely moving, carrying the frozen surface in patterns as gentle as breathing. The mountains rise from the edges of that plain, tall and bright, their methane-frosted peaks catching what little light the distant sun provides. From Pluto's surface, the sun appears only as a very bright star, smaller than a fingernail held at arm's length against the sky. Even so, that faint sunlight is enough to slowly drive Pluto's weather, to lift the methane and set it drifting again. Over the course of a Plutonian day, which lasts about 6 of our days, the frost shifts, sublimes, and settles once more. It is a cycle so slow and so cold that nothing on Earth quite prepares the imagination for it. Scientists have named some of these mountains after great explorers of Earth, Hillary and Norgay, who first stood on our own world's highest peak. It is a quiet tribute, naming frozen mountains no human being will stand on for a very long time, perhaps ever. And still the methane falls there, invisibly, soundlessly, building its pale frost on peaks that no footstep has ever disturbed. The spacecraft that showed us all of this has long since passed Pluto and is moving deeper into the outer darkness, still sending faint signals home. What it found on Pluto remains, in its quietest details, a thing science is still slowly piecing together. Why exactly the methane chooses those peaks, how the cycle works in the full length of Pluto's strange long seasons, is not entirely known. And so the frost keeps falling on those distant mountains, slowly and silently, in the cold of a world that waits patiently at the far edge of everything. Somewhere far out in the cold reaches of space, there is a moon called Iapetus, and it carries on its surface one of the strangest sights in the solar system. One half of Iapetus is almost perfectly white, like a sphere of clean winter ice reflecting distant sunlight. The other half is a deep, dusty reddish-brown, the color of old rust or dark earth left in the open air. This divide is so sharp and so complete that astronomers who first glimpsed it centuries ago could barely believe what they were seeing. Giovanni Cassini, observing from Paris in 1671, noticed that the moon seemed to vanish entirely on one side of its orbit around Saturn. When Iapetus moved to the other side, it reappeared, steady and bright, as if it had simply been sleeping somewhere unseen. For a very long time, nobody could say why a single moon should carry two such completely different faces. Running along the equator of Iapetus, threading between the bright and dark regions, there is a ridge unlike anything else we know of in the solar system. This ridge rises as high as 20 kilometers above the surface in some places, taller than any mountain on Earth. It stretches for thousands of kilometers, following the equator with an almost geometric precision that feels too deliberate for something that grew naturally. From above, the ridge looks like a seam, as if the two halves of this moon were once pressed together by hands too large to imagine. The ridge sits right along the boundary where brightness and darkness meet, which makes its presence feel even more quietly astonishing. Geologists and planetary scientists have looked at this ridge for decades and still cannot agree on how it formed. Some have suggested that Iapetus once spun much faster, and the ridge is the frozen memory of that earlier, more rapid life. Others have wondered whether rings of ice and debris once surrounded the moon and slowly collapsed, settling in a long quiet line along the equator. None of these ideas have been fully confirmed, and the ridge remains as open a question as the day it was first photographed. The two-tone coloring of Iapetus is itself a separate and equally quiet mystery layered beneath the ridge. The dark material on the leading side of Iapetus is thought to come partly from outside the moon, swept up as it travels through space. Tiny grains of reddish carbon-rich material, drifting in from distant moons, falls slowly onto one face over millions of quiet years. But the coloring is also deepened by something happening within Iapetus itself, a slow thermal process that darkens the already dark and brightens the already bright. Warmth from the distant sun heats the dark material, causing ice buried beneath to slowly migrate away toward the colder, brighter poles. Over immense stretches of time, this process separates the moon into its two great regions more and more completely, a slow and patient self-sorting. What is left is something that looks almost designed, a walnut-shaped world split cleanly between shadow and light. The walnut shape itself is real. Iapetus bulges noticeably at its equator, flattened at the poles in a way that matches an ancient, faster spin. If you could stand at the base of the ridge on Iapetus, you would see a wall of ancient ice and rock rising slowly into a sky without air. The ridge would cast a long still shadow across the dark plain below, and the silence would be the deepest kind of silence there is. Saturn itself would hang in the sky above, enormous and ringed, neither rising nor setting because Iapetus turns its same face always toward the planet. The rings of Saturn would cut across the sky in a thin bright line, and nothing would move, and there would be nothing to hear. In this stillness, the questions about the ridge and the coloring simply rest there unanswered, resting as they have for billions of years. Cassini, the spacecraft sent to study Saturn and its moons, flew close to Iapetus in 2007 and sent back images that filled scientists with new wonder. The photographs showed the ridge in finer detail than ever before, and in that detail the mystery only deepened rather than resolved. Scientists found that the ridge is not one continuous wall but a series of separate peaks and segments, interrupted by gaps and ancient impacts. The gaps themselves raise more questions than they answer, suggesting a history so long and so complicated that no single explanation has been enough. And so Iapetus continues its long slow orbit around Saturn, carrying its ridge and its two colors through the cold and quiet dark, unexplained and unhurried. The hour has drifted a little later now, and somewhere far beyond the familiar planets, a small cold world turns slowly in the dark. Makemake moves through the outermost reaches of our solar system, quiet and unhurried, orbiting the Sun in a path that takes centuries to complete. It is a small world, about 2/3 the size of Pluto, wrapped in a crust of frozen methane and ancient ice. And across its surface, there are patches, deep red, almost wine-colored, that no one has fully explained. Scientists first noticed the uneven redness when light reflected from Makemake reached telescopes on Earth. The colors were not uniform. Something on this world was absorbing light differently in some places than others. The reddish tones suggested something called tholins, complex organic molecules that form when simple chemicals are struck by cosmic radiation over millions of years. Tholins are not rare in the outer solar system. They color the haze of Titan and dust the moons of distant planets. But on Makemake, the patches are uneven, gathered in some regions and absent in others, as though something shaped them deliberately. One thought is that the patches may have formed where solar wind struck the surface most directly over long ages. Another quiet possibility is that internal heat, long ago, may have shifted certain compounds upward through the ice from below. Perhaps the patches mark places where the interior of Makemake once breathed outward, slowly and without drama, leaving color behind. There is no rushing this kind of change. On a world so cold and so far from the Sun, time moves differently. A single Makemake year lasts more than 300 Earth years, and the surface sits in a cold that barely changes. Whatever made those red marks was in no hurry at all, working across spans of time that make human history feel brief. The patches are not evenly spread. Some parts of the surface stay pale and bright, reflecting sunlight like fresh snow. Those bright regions are thought to be nitrogen or methane ice, pristine and cold, refreshed perhaps by slow cycles of frost. In certain seasons, and seasons on Makemake last for generations, the frost may migrate, shifting which parts stay pale and which redden. Slowly, over decades, the surface breathes in a rhythm too slow for any human to witness in a lifetime. No spacecraft has visited Makemake, and so what we know arrives only as light, faint signals interpreted from very far away. Each wavelength of that returning light carries a small piece of information, like a whisper crossing billions of kilometers. From those whispers, scientists have mapped the approximate color of its surface, warm russet in some places, pale silver in others. The russet patches have a quality that reminds some researchers of the reddish dust on certain asteroids, ancient and unaltered. There is something quietly striking about the idea that these colors are among the oldest organic materials in the solar system. Formed before the planets were fully shaped, preserved in the cold at the edge of everything, unchanged for billions of years. The patches hold a kind of silence, not threatening, simply very old, resting in the cold as they always have. A moon orbits Makemake, small and faint, discovered only by looking very carefully at old telescope images. The moon, named 2 Malawian Quachas, appears darker than Makemake itself, perhaps lacking the bright ice that covers parts of the parent world. Why the moon should be so much darker is another quiet question that floats without a firm answer. Perhaps it lost its ices long ago, or perhaps it was made of different material from the very beginning. For now it simply drifts in orbit, keeping its distance, saying nothing about itself that the light can fully translate. And so Makemake continues its long, unhurried circuit of the Sun, carrying its red patches like something half-remembered. No one has stood there, no instrument has touched that surface, and the color of those patches remains a gentle open question. Out in the deep cold, far past everything familiar, those red marks rest quietly, waiting for no one in particular. A slow wind moves across the outer solar system tonight, carrying nothing but cold and silence and the faint memory of sunlight. Far beyond Neptune, where the sun appears as little more than a bright star, a small world turns slowly in the stillness. This world is called Haumea, a dwarf planet shaped unlike almost anything else we have found drifting through the dark. It spins so quickly, completing one full rotation in only 4 hours, that its body has stretched outward at the equator like a worn stone. The surface is covered in almost pure water ice, reflecting sunlight in a pale, quiet glow across the emptiness around it. For a long time, astronomers watched Haumea carefully, noting its shape, its moons, its curious rapid spin. Then in 2017, something unexpected came to light, a discovery so quiet and so strange that researchers sat with it for many months before fully trusting what they had seen. As Haumea passed in front of a distant star, astronomers watching from Earth noticed something they had not expected. Just before the star disappeared behind the dwarf planet, its light dimmed slightly, as though something thin and transparent lay in Haumea's path. And when the star emerged on the other side, the same subtle dimming occurred again, perfectly symmetrical, perfectly calm. That gentle dip in starlight was the signature of a ring, a narrow band of material orbiting Haumea roughly 4,000 kilometers above its surface. It was the first ring ever discovered around a world in the outer solar system beyond the giant planets. No one had thought to look for rings around such a small, distant, egg-shaped world. The ring is not wide or dramatic like Saturn's great sweeping bands, but something far more delicate and far more difficult to explain. It sits in what is called a 3-to-1 resonance with Haumea's rotation, meaning each particle in the ring completes one orbit for every 3 full spins of the planet beneath it. This is unusual enough to give pause, because most rings we know elsewhere do not sit in such a tidy gravitational relationship with their parent body. No one yet fully understands how Haumea came to have a ring at all, or how that ring has survived the stresses of such a rapidly spinning world. Some researchers suggest the ring may be the remnant of a collision long ago, material scattered outward and caught gently in orbit. Haumea is itself believed to be a fragment of something larger, a body that broke apart in the ancient solar system and left its pieces drifting outward. 2 small moons, Hyakka and Namaka, circle Haumea as well, moving slowly and silently in wider orbits than the ring. Hyakka, the larger of the 2 moons, is itself covered in water ice and traces a gentle ellipse around its parent world. There is something quietly remarkable about this family of worlds, all water ice, all tumbling slowly through the same region of space. The ring itself is thought to be composed of water ice particles, the same material as the planet and its moons. At this distance from the Sun, water ice does not melt but simply remains, frozen and still, for billions of years. The ring moves in silence, as everything out here moves in silence, unhurried and indifferent to the passage of time. What puzzles scientists most gently is how the ring stays so narrow, so defined, when the spin of Haumea and the pull of its moons should slowly disturb it. There may be small shepherd forces at work, subtle gravitational nudges that keep the particles from spreading outward into formlessness. Or perhaps the ring is simply younger than it appears, not yet old enough to have been pulled apart by time. No spacecraft has ever visited Haumea, and none is currently on its way. Everything we know about Haumea's ring came from watching a single star blink quietly behind it, far away, on an otherwise ordinary night. That single event, measured carefully across several observatories on Earth, was enough to confirm something no one had imagined finding. And so Haumea sits out there still, spinning quickly and silently, its ring revolving steadily in the cold around it. No one knows how long the ring has been there, or how much longer it will remain before something shifts it quietly into a new shape. Somewhere in the outer dark, beyond all the familiar planets, a small egg-shaped world carries its ring gently through the cold, and no one yet knows quite why. Somewhere very far away, there is a silence so complete that even light takes hours to arrive there. Neptune drifts quietly near the edge of the solar system, wrapped in slow blue winds that have been turning for billions of years. And circling that cold blue world is a small moon called Triton, locked in a slow backward orbit that no one fully understands. When Voyager 2 passed close to Triton in 1989, the instruments fell quiet for a moment before they began returning something unexpected. The surface of Triton looked unlike anything seen before, a vast, wrinkled terrain that geologists slowly began calling the cantaloup terrain. Across the moon's western hemisphere, the ground is divided into shallow rounded depressions, each one pressed gently into the crust like the skin of a melon. Each depression is roughly 30 to 40 kilometers across, and they tile the surface in a pattern so regular it seems almost deliberate. There are no craters overlapping these depressions, which tells us slowly and quietly that this terrain is geologically very young. Scientists gave it the name because of how it looked, softly dimpled, rounded, patient, like fruit resting in a still kitchen in the early morning. No other moon in the solar system has a surface that looks anything like it, and that quiet strangeness has never been explained away. Triton is thought to be a captured object, something that drifted in from the cold outer reaches of the solar system long ago and was gently caught by Neptune's gravity. That long capture, scientists think, may have twisted and kneaded Triton's interior for millions of years, slowly reshaping everything from below. The cantaloup terrain, some believe, was formed by diapirs, great slow plumes of warmer, lighter ice rising from deep underground like silent balloons. Each rising plume pushed the surface crust upward and to the sides, creating the rounded rim of one soft depression after another. This process would have unfolded across an enormously long and unhurried span of time, perhaps hundreds of millions of years of slow interior movement. And yet the diapir theory, while quiet and careful and reasonable, has never been fully confirmed by direct evidence from the surface. There is a possibility, gently held open, that something else entirely shaped this terrain, something we have not yet imagined clearly. Triton's surface temperature sits near -230 degrees Celsius, cold enough that nitrogen exists there as frost. In places, that nitrogen frost catches the distant sunlight and glimmers faintly across the ridges between the depressions. The sun, seen from Triton, is only a very bright star, small and cold and far, and the light it casts is quiet and thin. Even so, that thin light is enough to drive slow geysers, columns of nitrogen gas rising gently from the warmer subsurface and drifting away as dark plumes. Voyager 2 photographed several of these rising plumes, and they drifted downwind like smoke from a very distant fire no one could see. The cantaloup terrain and these geysers coexist on the same small world, each one hinting at a buried warmth the instruments could only partly measure. Beyond the cantaloup region, Triton's surface changes, smooth plains, frozen lakes of old nitrogen, ridges that run for hundreds of quiet kilometers. The cantaloup region covers only part of Triton's surface, the rest remains unphotographed, turned away from Voyager as the spacecraft made its single pass. More than half of Triton's surface has never been seen at close range, and what lies beneath the cantaloup on the other side remains entirely unobserved. That quiet fact, that most of this strange world has never been mapped, sits gently in the mind like a small stone in still water. Scientists have proposed sending another mission to the Neptune system, a slow patient journey that would take well over a decade to arrive. If that mission flies, it may one day drift into Triton's orbit and look down slowly at the cantaloup terrain from above. Until then, the terrain rests undisturbed, dimpled and quiet, turning slowly in the long cold dark beyond the reach of any other visitor. The depressions in that crust have been there, in their soft rounded shapes, for longer than most things we can easily imagine. They hold no footprints, no instruments left behind, no signal of any arrival, only the slow turning of an old cold world. And somewhere in that still and dimpled landscape, the answer to what shaped it rests quietly, waiting with all the patience of deep space. Triton drifts on through the cold, its surface unchanged, unhurried, carrying its quiet mystery across the slow centuries without a sound. Somewhere far from any shore, light falls differently, softer, more diffuse, arriving across a distance so vast it seems to arrive already tired. This is Dione, one of Saturn's quieter moons, drifting in its slow orbit where the ringed planet fills a large portion of the sky. From a distance, Dione appears pale and almost uniform, like a smooth stone worn by a river over many centuries. But something about Dione is not quite even, not quite the same on all sides, and this asymmetry has puzzled those who study it for a long time. One side of Dione faces forward as it moves through its orbit, and the other side trails behind, always facing the direction it has already traveled. The trailing hemisphere glows with a brightness that the leading side simply does not share, as if one half of this moon has gathered more light somehow. Ancient ice on the trailing side catches the sun and returns it cleanly, like a fresh snowfield on a clear morning before anyone has walked through it. The leading hemisphere, by contrast, carries a faint warmth to its tone, not dramatically different, but enough that instruments can read the difference clearly. Scientists call this difference in reflectivity and asymmetry in albedo, and it has been observed across several of Saturn's moons, not Dione alone. One idea is that charged particles from Saturn's magnetosphere rain down preferentially on the trailing side, altering the chemistry of the ice there very slowly. These particles, drifting outward from Saturn over immense spans of time, would settle into the ice and gradually lighten it through a process called radiolysis. In radiolysis, radiation splits water molecules apart and the resulting oxygen slowly bleaches the surface, the way old paper slowly brightens when kept from sunlight. But the leading side is swept by something else, micrometeorite impacts arriving in a steady slow rain over billions of years. Each tiny impact churns the surface ever so slightly, mixing darker material up from below the cleaner ice above, dulling the reflectivity grain by grain. This process is called impact gardening, and it happens so slowly that no human timeframe could ever witness even a single perceptible change. The moon has been accumulating these impacts since long before Earth had oceans, and the record of that accumulation is written in the brightness of its hemispheres. Voyager glimpsed Dione briefly in 1980, and the images it returned showed wispy white streaks on the trailing hemisphere, bright lines crossing the darker terrain. Those streaks turned out to be cliffs of ice, bright fracture lines where the moon's crust had split and clean interior ice had been exposed to space. Cassini arrived decades later and spent years in the Saturn system, returning to Dione again and building a far more detailed portrait of this quiet world. Each close pass revealed the trailing hemisphere glowing gently brighter than the leading side, consistent across every viewing angle and every lighting condition. The difference is not enormous, perhaps 15 to 20% brighter on the trailing side, but it holds steady across all the data, quiet and unexplained. Some researchers have suggested that subtle variations in Saturn's magnetic field might create uneven heating across the moon's surface over geological time. Others point to the possibility that Dione's interior still holds some warmth, and that this warmth rises and resettles the surface in ways not yet fully understood. There is even a thin suggestion of a subsurface ocean deep within Dione, a hypothesis that remains unconfirmed and perhaps unconfirmable with current instruments. The brightness difference, wherever it comes from, has persisted through billions of years of slow bombardment, of radiation, of orbital resonance with Saturn's other moons. Dione moves in a steady rhythm with Enceladus, locked in a 2-to-1 resonance where Enceladus orbits exactly twice for every orbit Dione completes. This gravitational conversation between the two moons creates tidal flexing deep inside Dione, the slow creak of rock and ice that may generate internal heat. The heat from that flexing, if it exists at the right depth, could drive subtle surface processes that unevenly affect the trailing and leading sides differently. And yet no single explanation has closed the question entirely. Each hypothesis accounts for part of what is seen but not quite all of it. The asymmetry simply remains, patient and unresolved, held in place by whatever combination of forces shaped this moon over its long and quiet history. Far out in the Saturn system, where the Sun is only a bright star and the rings spread in silence, Dione continues its slow orbit without announcement. Its trailing side catches the distant starlight and returns it faithfully, the same brightness it has maintained across a span of time almost impossible to hold in mind. The leading side follows behind in its own quieter tone, a little muted, a little worn, carrying the long record of everything that has drifted its way. And so Dione drifts on, one side bright and one side softer, a small persistent difference in a very large and unhurried universe. There is a silence out here that has no bottom, a quiet so complete it feels like the universe itself has stopped to rest. Somewhere at the very edge of the known solar system, a small round world drifts slowly through the cold. That world is Pluto, and it carries above it something no one expected to find so far from the Sun. A haze, blue and layered and impossibly beautiful, wrapping the little planet in something almost like breath. When the New Horizons spacecraft passed by in the summer of 2015, its cameras turned back and caught that blue glow. The image came back across 3 billion miles of emptiness, and the scientists who received it went very quiet. They had expected gray or no color at all, because Pluto is so remote and so cold. But the haze was unmistakably, gently, softly blue. There are at least 20 distinct layers in that haze, each one resting above the last like pages of a slow book. Each layer sits at its own altitude, held there by forces too delicate to fully trace. The blue color itself comes from tiny particles called tholins, made when sunlight breaks apart simple gases in the cold thin air. Tholins are a rust-red color when gathered together, and yet in the haze they scatter light in a way that reads as blue. It is a gentle contradiction, a mystery written in color, resting quietly above a world no human has ever stood on. Pluto's atmosphere is extremely thin, just a whisper of nitrogen and methane and carbon monoxide. And yet within that whisper, something is happening that keeps the haze layered so precisely. Scientists think that waves of pressure move slowly through the atmosphere, bending the layers into their gentle tiers. But the full reason the layers hold so neatly, so evenly, so quietly, remains something no model has perfectly explained. The atmosphere itself breathes with the seasons, and on Pluto a season lasts longer than a human lifetime. As Pluto moves closer to the Sun on its long elliptical path, surface ices warm ever so slightly and rise into the air. The atmosphere thickens slowly, and the haze deepens, and then Pluto moves away again into the long cold. When that happens, the gases settle back down onto the surface as frost, and the haze fades, and the silence returns. This slow exchange between sky and ground has been going on for billions of years, without anyone to witness it. The blue haze rises and settles, in a rhythm measured not in hours but in centuries. The tallest haze layer reaches nearly 200 kilometers above the surface, higher than most satellites orbit Earth. Up there, the particles are so sparse and so small that they barely touch each other as they drift. They hang suspended in the cold, turning slowly, scattering the faint sunlight that reaches this far. The Sun from Pluto is just a very bright star, far smaller in the sky than it appears from Earth. And yet that distant point of light is enough to drive chemistry, to make the haze, to color it blue. It is one of the quieter wonders of the solar system, unannounced, patient, happening without pause. The tholins that form in the haze eventually drift downward, settling gently onto the surface like very cold snow. They color parts of the surface a deep reddish brown, the signature of chemistry repeated across geological time. The same blue haze that touches the top of the sky eventually becomes the red-orange ground beneath it. No one has gone back to watch this happen, and no one knows exactly when they will. And so the blue haze continues to gather and drift and settle, far out in the dark, all on its own. Far out in the solar system, where sunlight arrives thin and pale and almost colorless, a small world drifts in silence. The light here is gentle and ancient, traveling so far before it finds anything to touch. This is Comet 67P, a traveler that has orbited the Sun for billions of years, quietly following its long elliptical path. When spacecraft cameras first captured its full shape from a distance, scientists grew very still and very quiet. What they saw was not the rough potato shape they had expected, nor the smooth sphere of older imagination. The comet was shaped, unmistakably and strangely, like a rubber duck. Two rounded lobes of rock and ice, joined at a narrow neck, tumbling slowly together through the dark. The larger lobe is the body, broad and cratered, covered in cliffs that catch the thin sunlight and cast long soft shadows. The smaller lobe sits above it like a head, rounded and quieter, its surface smoothed by dust and time. Between them, the neck is the narrowest passage, a valley worn thin where the two worlds press gently together. Nobody truly knows how this shape came to be, and that uncertainty has rested quietly in the minds of scientists ever since. One possibility, held gently and not yet proven, is that two separate comets drifted together over unimaginable time. They may have touched at the slowest speed imaginable, slower than a person walks, and stayed. Another possibility is that a single comet eroded away at its middle over billions of years of sunlight and sublimating ice. Each time the comet swings close to the Sun, jets of gas and dust breathe outward from its surface like slow exhalations. Those jets carve and shape the comet over millions of years, grain by grain, in the patient arithmetic of deep time. The Rosetta mission traveled for 10 years across the solar system to arrive at this strange double world. When it finally drew close enough to see clearly, the team gathered around their screens and simply looked for a long time. The comet rotates slowly, completing one turn roughly every 12 hours, leisurely as a planet at rest. As it turns, different cliffs and plains come into the pale light, each one briefly illuminated before turning gently away. There are places on this comet where the cliffs are taller than some of Earth's greatest mountains, standing in total silence. The Philae lander descended toward this surface one quiet November, tumbling and bouncing in the near-zero gravity. It came to rest in shadow, tilted against a cliff, sending back signals for a little while before going quiet. Even now, nobody is completely certain why the neck region of this comet glows more smoothly than the rough lobes around it. Fine dust settles there like a quiet snowfall, collecting in the gravitational lobe between the two bodies. The comet carries water ice within it, ancient water from the earliest moments of the solar system's formation. Some scientists have wondered whether comets like this one carried the seeds of oceans to young planets long ago. That question, too, drifts unanswered, floating alongside the comet in the long quiet between the planets. The rubber duck shape of 67P remains one of the more gentle puzzles in planetary science, unexplained and unhurried. Perhaps the two lobes were always one, carved by time and sunlight into this unlikely silhouette. Perhaps two ancient wanderers found each other in the slow dark of the outer solar system and gently held on. Either way, the comet continues its patient circuit around the Sun, unchanged by our wondering, untroubled by our questions. It will return again, and again after that, this quiet double world drifting through the light of a sun it has always known. And somewhere far below, someone resting in the dark may look up and wonder, without needing an answer, at this strange and gentle shape. Quietly now, the mind lifts away from wherever it has been resting, drifting upward past clouds and silence, until it settles gently at the edge of space. Far from the warmth of Earth, a small moon turns slowly in the rust-colored light of Mars, ancient and unhurried. This is Phobos, the nearer of Mars's two moons, no larger than a city, drifting in its quiet orbit day after day. And on its surface, carved deep into its dusty gray skin, lies the wide bowl of Stickney crater, older than memory. Stickney is enormous for a moon so small, stretching nearly 9 kilometers across, almost a quarter of Phobos itself. The impact that made it must have shaken the whole moon to its core, yet somehow Phobos held together, trembling and still. What remains inside that crater now is something quieter and stranger than anyone expected to find. The terrain inside Stickney does not follow any simple rule that geologists had imagined for a moon this size. Slopes that should be smooth are broken and folded, as though the ground itself forgot what direction was down. Enormous boulders rest in places they could not have rolled to, as if they were set down gently by some invisible tide. Long grooves run across the floor of the crater and outward across the whole moon, straight and deliberate looking, like old scars. No one has agreed on what carved them so precisely, and the question rests there still, unanswered and gentle. From orbit, spacecraft have looked down into the crater and mapped its floor with careful patience, instrument by instrument. And each new image has added not an answer, but a deeper layer of quiet strangeness to what lies below. There are regions inside Stickney where the surface is unusually blue, cooler in color than the surrounding moon, for reasons still uncertain. Perhaps fresher material was exposed when the crater formed, revealing what had always been hidden just beneath the surface. Or perhaps something else entirely shaped that coloring, something the data has not yet found a name for. Loose material at the crater's rim sits at impossible angles, neither fallen nor quite stable, as though gravity here is undecided. Phobos orbits so close to Mars that the pull of that great planet complicates every calculation about how things settle here. The tidal forces from Mars stretch and squeeze the little moon in a slow, constant embrace that has lasted billions of years. Some researchers believe the grooves are the moon's own quiet response to that pressure, hairline fractures from a very long embrace. Others suggest the grooves formed in the first moments of the Stickney impact, rippling outward like rings in still water. Both explanations are reasonable, and neither one has yet closed the question entirely. Inside the crater, a fine dust called regolith coats everything in a pale, powdery layer, undisturbed for ages. That dust, if you could stand in it, would behave strangely, drifting up at the lightest touch and settling back very slowly. Gravity on Phobos is so faint that a person could leap gently and float for nearly 10 minutes before returning to the ground. In that almost weightless silence, the chaotic terrain of Stickney would feel very far from the solid world we know. Phobos is drawing slowly closer to Mars, a few centimeters every year, in a long, patient spiral toward its end. In perhaps 30 or 40 million years it will cross too close, pulled apart by tidal forces into a ring of debris. But for now it continues its quiet rounds, 3 times a day rising and setting over the Martian sky, unhurried. And at the center of its battered surface, Stickney crater rests as it always has, open and still and unresolved. The chaotic terrain inside it holds its shapes without explanation, boulder by boulder, groove by quiet groove. Whatever shaped this place so strangely happened long before any eye was watching, and left no clear record behind. And so the little moon keeps turning in its rust-colored light, carrying its unanswered questions gently through the dark. Far from any ocean, far from any stone shore, the mind drifts upward now, into the cold and quiet of open space. There is a small moon, not so far from Saturn, that sits quietly among the rings like a pale smooth stone. It is called Enceladus, and at first glance it looks like little more than a perfectly still, perfectly white world. Its surface is among the most reflective in the entire solar system, bright as fresh snow on a winter morning. But toward the south, something stirs beneath that stillness, something slow and warm and ancient. There, long fractures run across the ice like quiet cracks in old porcelain, glowing faintly with warmth from below. These fractures are called tiger stripes, and they are unlike anything else we have ever seen on any moon. From within these openings, water rises, carrying heat from somewhere deep inside the little moon. And then, slowly, it escapes into space as great plumes of ice and vapor drifting silently outward. You might imagine standing at the edge of one of these cracks and watching the vapor rise slowly around you. The sound, if there were any, would be a very soft hiss, like the quietest of all possible winds. The geysers of Enceladus shoot material more than 100 kilometers into the sky above the moon. Some of it falls back as the finest imaginable snow, dusting the South Pole in a perpetual soft white layer. But much of it escapes the moon entirely, drifting outward to become part of Saturn's outermost ring. In this way, Enceladus has been quietly building one of Saturn's rings for millions upon millions of years. The plumes themselves contain water vapor, and also traces of salt, and silica, and organic molecules. Salt in the plumes means there is a liquid ocean beneath the ice, and the salt comes from that ocean touching rock. Deep below the frozen surface, warmed by the tidal pull of Saturn, a whole sea moves in darkness. It is thought to be a global ocean, wrapping all the way around the interior of the moon in every direction. On the ocean floor of Enceladus, there may be hydrothermal vents, warm openings where minerals pour into the water. On Earth, those same kinds of vents support entire communities of creatures, thriving in places where sunlight never reaches. Nobody can say with certainty what Enceladus holds within its hidden sea, and that question rests unanswered still. The Cassini spacecraft spent years drifting through the Saturn system, listening and measuring as it passed. Cassini flew directly through the plumes of Enceladus, tasting the material as it fell around the spacecraft. What it found there, in those delicate threads of ice and vapor, surprised the scientists waiting on Earth. Hydrogen, the kind produced when hot rock meets water, was flowing outward from Enceladus with every eruption. That hydrogen is a kind of chemical energy, the same sort of energy that living things on Earth use to sustain themselves. And so the little moon goes on erupting, quietly and continuously, year after year, in the cold beyond the asteroids. It does not know it is being watched, or wondered about, or thought of as one of the strangest places in the solar system. It simply erupts, and drifts, and circles Saturn as it has done for longer than any human history can reach. And perhaps somewhere inside it, beneath all that ice and all that cold water, something very small is simply living. Or perhaps it is only water and warmth and the patient work of chemistry, slow and undisturbed across the eons. There is no answer yet, only the plumes rising and the questions drifting outward with them into the dark. And the little moon continues its slow circle around Saturn, erupting softly, carrying its secret still. Imagine drifting high above the solar system, rising slowly until the planets become soft points of pale light below you. And then, gently, you descend toward a small and distant moon, silver-gray against the dark, orbiting the tilted giant Uranus. This is Miranda, one of the smallest of Uranus's moons, a quiet and ancient world roughly 500 kilometers across. It is a still place, cold and unhurried, where nothing moves and time seems to have paused somewhere very long ago. And there, on one side of this silent little world, the ground simply ends. It drops away in a single sheer face, a wall of ancient rock that descends for somewhere close to 20 kilometers straight down. This is Verona Rupes, the tallest known cliff in the entire solar system, and it stands on a moon most people have never heard of. Only one spacecraft has ever passed close enough to see it, and that passage lasted just a handful of hours. Voyager 2 swept past Miranda in January of 1986, and in those few hours it gathered almost everything we know. The images it returned were startling, showing a surface unlike anything scientists had expected to find. Where other moons are smoothed by time, Miranda is folded and torn, as if something immense once rearranged it from within. There are coronae on Miranda, strange roughly oval regions where the terrain is grooved and ridged in concentric patterns no other world quite shares. Scientists have offered explanations over the years, but none has settled quietly into certainty. Some have suggested the moon was shattered by a collision long ago and then slowly drew itself back together, imperfectly. Others point to tidal heating from Uranus, a slow internal warmth that might have pushed and buckled the surface from below. But for now, no single answer explains all of what Voyager's cameras recorded, and Miranda keeps its reasons quietly to itself. And above all of this geology, above the coronae and the cracked plains, Verona Rupes simply waits. To stand at its edge, if one could, would be to look down a wall of stone that disappears into distance far below. 20 kilometers is a difficult distance to hold in the mind, taller than the highest mountain on Earth by more than twice. And because Miranda's gravity is so very gentle, something dropped from the top of Verona Rupes would fall for about 10 minutes before reaching the base. 10 quiet minutes of falling through silence, through cold and airless space above an alien moon. The cliff face itself is layered, pale lines of ancient stone one above another, each layer a record of something that happened very long ago. What each layer holds, what events wrote themselves into the stone of this distant moon, remains a question with no clear answer. Miranda itself orbits Uranus at a distance of about 130,000 kilometers, closer than our own moon is to Earth. From Miranda's surface, Uranus would fill a large portion of the sky, its pale blue disk hanging enormous and very still. And the sun from out here is only a bright point among stars, giving light but very little warmth. It is a quiet and very remote kind of beauty, this moon with its impossible cliff, sitting patiently at the edge of the known solar system. No mission is currently on its way to Uranus, and Miranda rests undisturbed, as it always has. Scientists propose returning someday, sending a new probe that might orbit long enough to map the cliff and read the layers of its stone. Until then, the images from Voyager remain the only record, a few hours of photographs from a journey that will never be repeated. And somewhere out in the cold and unlit reaches beyond Neptune, Voyager 2 continues on, carrying its cameras now pointed toward the stars. Behind it, Miranda turns slowly in the pale light of a very distant sun, its great cliff face catching the same soft glow it always has. The cliff asks nothing, offers nothing, simply stands as it has stood for perhaps billions of years, unhurried and immense. And there it will remain, long after tonight has passed, patient and quiet on that faraway moon no one has ever visited. Somewhere far from the warmth of Earth, in the cold quiet reaches beyond Mars, there drifts a small and forgotten moon. Deimos is very small, smaller than most cities, and it turns slowly in the long Martian shadow. What draws the eye, slowly and without hurry, is the surface itself, impossibly smooth, as though something long ago quietly ironed it flat. Most small moons wear their age openly, scarred by craters and jagged rubble, but Deimos rests beneath a deep, even blanket of dust. This layer, called regolith, is fine and pale, draped gently over almost every feature the moon once had. Scientists who first studied the photographs from Voyager and Viking stopped, looked again, and quietly wondered. The smoothness was not what anyone had expected from a captured asteroid tumbling through the solar wind for billions of years. On most bodies this ancient, every impact leaves a permanent mark, a bowl of stone and scattered rock that never heals. But Deimos seems to have forgotten its wounds, or perhaps buried them, softly and completely, beneath this quiet gray layer. The regolith on Deimos is extraordinarily fine-grained, almost like powder, and it lies in a layer perhaps 100 meters deep in places. 100 meters of accumulated quiet, settling over eons, undisturbed by wind because there is no wind here at all. In the absence of any air, every grain of dust that rises must eventually come back down, slowly, in the moon's faint gravity. And Deimos's gravity is so gentle that if you stepped there, you would feel almost nothing holding you to the ground at all. A pebble thrown upward would arc away slowly and perhaps never return, drifting instead into the long darkness between worlds. And yet the dust remains, patient and still, hugging the surface in a layer so even it almost seems deliberate. There are craters on Deimos, a few of them, but they are shallow and softened, as though time has been gently pressing them down. The largest is called Swift, and even it rests quietly beneath its own smooth interior, the wall's gentle slopes rather than sharp cliffs. Nobody has been able to say, with certainty, how the regolith grew so thick and so even across a body this small. Some have suggested that impacts elsewhere in the solar system sent fine material drifting slowly outward, and Deimos gathered it over time. Others have imagined the regolith shaking gently after each small tremor, slowly spreading and evening itself out like still water finding its level. But neither explanation sits quite comfortably, and the smoothness remains a question left gently open. At this point in a long, still night, there is something restful about not knowing, about letting the question simply float. Mars hangs in Deimos's sky, enormous and rust-colored, turning slowly, always there but never reaching. From that distance Mars looks warm, though of course it is not, and the light it casts back onto Deimos is thin and cool. The regolith absorbs this thin light and gives almost none of it back, making Deimos one of the darkest objects in the inner solar system. And yet in photographs it shows itself clearly, every gentle ripple in the dust catching just enough light to be seen. There is something in those photographs that is almost peaceful, a surface that has been resting for a very long time. The dust has been settling, grain by grain, across timescales so large they have no comfortable name in ordinary language. Perhaps the smoothness is simply patience made visible, the long unhurried work of a small world tidying itself. Whatever shaped it, the blanket lies undisturbed now, as it has for longer than there have been eyes to wonder at it. Somewhere beneath that dust there may still be craters, ridges, the old record of everything Deimos survived to get here. But all of that is quiet now, folded under, resting beneath the soft gray weight of accumulated time. And Deimos continues its slow orbit, carrying its smooth and mysterious surface through the long cold between Mars and nothing. It asks no questions and offers no answers, only that still, even blanket of dust, resting in the quiet of deep space. Far out beyond the warm inner planets, where sunlight falls thin and cold across ancient ice, there drifts a small and peculiar moon. This is Hyperion, a frozen, tumbling world orbiting Saturn, shaped not like any tidy sphere but like something worn and hollowed by time. Its surface does not look like rock so much as a vast, quiet sponge, riddled with deep holes and soft-edged hollows stretching in every direction. Scientists who studied the first images sent back could barely believe how porous it was, like the inside of a bone left very long in still water. And among all its strange hollows and gentle craters, one feature in particular drew the eye and held it quietly. Two craters, side by side, nearly touching, resting together on the porous plain like two slow impressions pressed into very old dough. The double crater sits in quiet stillness, undisturbed, exactly as it has rested for perhaps hundreds of millions of years. There is something very restful about a place that has not changed, not shifted, not been touched by wind or rain or any living hand. Hyperion tumbles as it orbits, slowly turning with no fixed axis, drifting through its path around Saturn in a kind of slow, dreaming roll. Most moons of Saturn hold still, turning steadily and predictably, but Hyperion refuses that regularity and simply wanders. It is one of the largest known bodies in the solar system with a completely chaotic, unpredictable rotation, and nobody is entirely sure why. Because it tumbles so unpredictably, the sun falls across the double crater from different angles at different times, lighting it in ways never quite repeated. Sometimes the craters sit in full, pale sunlight, their rims casting the gentlest shadows into their hollow floors far below. The floors of the craters are themselves pocked with smaller hollows, as if the sponge texture continues all the way down into the deepest places. What made the sponge pattern to begin with remains one of the quieter puzzles in planetary science, discussed carefully and without resolution. One idea is that the ice and dust of Hyperion compact strangely, collapsing inward where craters form rather than splashing material outward. Another thought is that sunlight slowly evaporates the ice from crater floors, leaving the deep pits permanently emptied and hushed. But neither explanation fully accounts for the particular stillness of the double crater, for why two impressions rest so close together and no larger third one formed. A double crater like this most likely came from a binary impactor, two small rocks traveling together through space and arriving at the surface as one event. In the vastness of the outer solar system, small rocks sometimes orbit each other the way moons orbit planets, locked in quiet company. Two such companions, drifting slowly for perhaps millions of years, may have finally met Hyperion together on one unremarkable ancient day. There would have been no sound, because there is no air on Hyperion, only a silent, slow settling into the soft ice and dust. The material did not fly outward the way it might on a denser world, but sank quietly into the porous body below. And then the double crater simply rested, undisturbed, while Saturn continued turning slowly in the distance, its rings spread wide and pale. The Cassini spacecraft passed close to Hyperion in 2005 and again in later years, its cameras turning quietly toward the sponge surface below. The images it returned showed the double crater in detail no eye had ever seen before, two quiet circles side by side in the ancient amber light. Scientists measured the craters carefully, traced their edges, mapped the hollows in their floors, and still found themselves uncertain about much. The density of Hyperion is so low that it is mostly empty space inside, more hollow than solid, lighter than water would be if gathered into its shape. Sitting with that thought in the quiet is its own kind of wonder, a moon-sized shape of ice and emptiness drifting patiently around a giant planet. The double crater rests on its surface the way a thumbprint rests in cold clay, gentle and permanent and very still. No wind will ever fill it, no rain will ever soften its edges, no footstep will ever disturb the fine dust lying undisturbed on its floor. Out here in the cold reaches of the solar system, time moves in a different way, long and unbroken and without urgency. The double crater has kept its shape through all of that slow time, patient and unchanged, holding whatever quiet story it carries without telling it. And Hyperion continues its slow tumble through space, carrying that still impression gently forward, through the cold and the dark and the long years. Let the mind drift back 4 decades, to a quieter era of exploration, when a small spacecraft sailed silently past the ringed giant we call Saturn. Voyager was a modest machine, really, a gold foil-wrapped traveler carrying instruments tuned to listen, measure, and photograph whatever it found. Scientists on Earth waited for its transmissions, sitting in quiet rooms surrounded by softly humming equipment, patient as the signal crossed the dark. What arrived, slowly, in the data, were images of Saturn's rings unlike anything anyone had imagined possible. The rings had always seemed, from Earth, like smooth flat disks of ice and rock, orderly and unchanging across the centuries. But threading across those ancient bands of ice, Voyager saw something strange and gentle, dark, radial streaks stretching outward like spokes on a wheel. The spokes were enormous, longer, in fact, than the full width of the Earth, and yet they had formed in what seemed, cosmically, like a breath. They rotated with the planet, these quiet shadows, moving in slow procession around Saturn like the hands of some immense and unhurried clock. To planetary scientists of that time, this should not have been possible. The inner edges of the spokes moved faster than the outer edges, and yet they held together. In a ring made of particles all orbiting at their own speeds, any marking should have sheared apart within minutes, stretched into nothing by the Keplerian flow. And yet the spokes did not shear, did not dissolve, they simply drifted onward, serenely defying the orbital physics that governed everything else in that place. The leading theory, arrived at gently over many years, involves tiny grains of ice lifted above the ring plane by electrical forces in Saturn's magnetic field. Saturn's enormous magnetic field rotates with the planet, and when it sweeps past the rings it can, in theory, loft fine particles up and hold them suspended. Those lifted grains, hovering just above the main ring plane, would catch sunlight differently, appearing dark when lit from one angle, bright when lit from another. It is a delicate process, almost gentle, fine ice grains held aloft on invisible magnetic currents for hours before settling softly back down. The spokes seem to form mostly near Saturn's shadow boundary, where sunlight ends and the long cool shade of the planet falls across its own rings. Something about that boundary, the crossing from light into shade, the sudden shift in charging conditions, seemed to encourage their quiet appearance. Voyager 1 photographed them, and then Voyager 2 passed months later and photographed them again, patient confirmation that these were real and repeating. For a long while after that, Saturn drifted beyond easy observation, and the spokes waited, unexamined, in a quieter corner of astronomical memory. When the Cassini spacecraft arrived at Saturn in 2004, scientists wondered quietly whether the spokes would still be there, or whether they had somehow faded. In Cassini's earliest images, the B-ring appeared smooth and unmarked, the spokes were absent, and for a time there was a quiet puzzlement among the ring scientists. Saturn had been near its solstice then, tilted so that its rings faced the sun more directly, and researchers came to believe that geometry mattered greatly. As Saturn moved toward its equinox in the years that followed, the ring plane tilted edge-on to the sun, and the spokes returned, slowly and softly. Cassini watched them form and dissipate over days and weeks, each spoke lasting perhaps a full rotation of the planet before softly coming undone. They tend to appear in clusters, these quiet features, forming in a zone of the B-ring and moving together in that slow, collective drift around Saturn. The B-ring, where spokes form, is the broadest and most opaque of Saturn's rings, a dense province of ice that has orbited the planet for an incomprehensible span of time. Those same ice particles that carry the spokes have likely been circling Saturn since long before anything alive existed on the small blue world we call home. And still the details of spoke formation remain, in some quiet ways, open, the precise triggering mechanism not fully settled, the full picture still unfolding. Some researchers suggest that meteoroid impacts into the ring plane release clouds of vapor that quickly become electrically charged and rise, a quiet violence producing a gentle mark. Others point to the magnetosphere itself, Saturn's vast invisible field that rotates like a slow breathing in the space around the planet, touching everything within it. There is something quietly remarkable about standing at the edge of knowledge, where a phenomenon can be seen clearly, named, photographed, measured, and still remains somewhat open. Cassini ended its mission in 2017, descending into Saturn's atmosphere in a final long slow arc, and since then, no spacecraft has watched the spokes form. The spokes are still there, almost certainly, still forming near the shadow line, still drifting in their slow procession around a planet that never hurries. And in the silence between transmissions, in the long unmeasured hours of the present, Saturn turns, unhurried, ancient, its rings tracing their patient arcs through space. Far beyond the warm blue oceans we have been drifting above, millions of miles deeper into the cold quiet of space, there rests a small frozen moon. Mimas moves in slow silence around the giant ringed planet Saturn, a pale sphere no larger than the state of Spain. From a great distance it appears unremarkable, simply another faint icy world drifting in the long cold dark between the planets. But when a spacecraft draws closer, something extraordinary becomes slowly, gently visible on its face. A single enormous crater marks the surface of Mimas, so wide and so perfectly round that it seems almost like something placed it there with great care. This crater is called Herschel, named quietly after the astronomer who first saw Mimas itself through his long telescope in 1789. William Herschel spent long evenings in his garden in England, turning his handmade telescopes gently toward Saturn and watching its moons drift around the planet. He would not have guessed that the small moon he had found bore a wound so deep it nearly shattered it entirely. Herschel crater stretches across nearly 1/3 of the entire diameter of Mimas, a proportion almost impossible to imagine on a world this small. The walls of the crater rise to 5 kilometers in height, tall as many of Earth's greatest mountains, and they encircle a floor of pale scarred ice. At the very center of the crater, a rounded mountain of ice pushes up from the floor, the rebounded heart of an ancient terrible collision. Whatever struck Mimas long ago struck it with such force that the entire moon shook, and geologists believe it came very close to breaking apart. On the opposite side of the moon from the crater, the surface is scored with strange grooves and ridges, as though the shockwave passed entirely through the body of Mimas. It is a quiet reminder of how violent the early solar system once was, and how long ago that violence ended. When the Voyager 1 spacecraft swept past Mimas in 1980, it sent back the first images of Herschel, and scientists saw at once the resemblance no one had expected. The crater, with its high circular rim and central peak, looked almost precisely like the fictional space station from a film released only 3 years before. Scientists allowed themselves a quiet smile at that coincidence, and for decades the name Death Star Moon followed Mimas gently through the literature. The Cassini spacecraft, which arrived at Saturn in 2004, spent years making slow patient passes near Mimas and gathering something no camera alone could reveal. Cassini's instruments measured the gentle wobble in Mimas as it traveled around Saturn, and what they found was quietly puzzling. Mimas wobbled more than it should, rocking very slightly back and forth in a rhythm that could not be explained by its shape alone. Something inside Mimas was responding to Saturn's gravity in an unexpected way, something hidden beneath all that cold scarred ice. One possibility offered gently by scientists is a liquid ocean, an ocean buried perhaps 30 kilometers beneath the surface of this small frozen moon. If it exists, that ocean has never touched a crack or a vent, has never shown itself at the surface in any form anyone has been able to see. Mimas shows none of the warm streaks or geysers that mark its neighbor Enceladus, and yet something beneath it stirs in a way that numbers suggest. Perhaps the ocean is very young in geological terms, perhaps it formed only recently and has not yet had time to reach the surface. Or perhaps the shape inside Mimas is something else entirely, an irregular rocky core that simply throws off its balance in a way that mimics an ocean's pull. No one has yet settled the question, and Mimas continues its slow circuit around Saturn, carrying whatever it holds quietly inside. Saturn's rings spread out in vast flat silence beyond the moon, and Mimas drifts among their inner edge, almost grazing the broad sheet of ice and rock. There is a gap in Saturn's rings called the Cassini division, and Mimas plays a gentle gravitational role in keeping that gap open across all those years. Each time a ring particle completes 2 orbits, Mimas completes exactly 1, and this steady rhythm slowly sweeps that region clear. It is a kind of slow music written in gravity, played out across millions of years without interruption or variation. Mimas itself remains largely unchanged by all of this, its ancient cratered face still bearing that one enormous wound from long before any of this was understood. Herschel crater sits there quietly in the light that filters down from the distant sun, patient, unchanged, and still not fully understood. And somewhere far below that still white surface, if the numbers are to be trusted, something liquid and hidden moves in the long slow dark. The hour has drifted a little later now, and somewhere far beyond the familiar planets, a frozen world turns slowly in the dark. This is Ariel, one of the moons of Uranus, a place of ice and ancient stone valleys that stretch for hundreds of miles across its surface. When the Voyager 2 spacecraft drifted past in 1986, it sent back images that left scientists quietly puzzled for decades to come. The valleys on Ariel are wide and deep, carved into the surface as if the moon itself had slowly pulled apart at the seams. And along the floors of those valleys, something unexpected waited, smooth, warm-toned deposits unlike the bright ice above. The floors are unusually dark compared to the rest of Ariel, which is one of the brightest moons in the entire solar system. Scientists gave names to these valleys: Kachina Chasma, Corrigan Chasma, quiet names from folklore and legend. Kachina Chasma runs for nearly 1,000 kilometers, a slow, curving wound across the face of this silent world. The walls of the canyons rise steeply, layered in pale gray and cream, like pages of some very old and unread book. And at the bottom, that strange dark material rests, smooth, unhurried, as if it simply settled there long ago and never moved. Nobody has been able to explain, even now, precisely what that material is or where it came from. Some scientists suggest it may be carbon-rich material, carried up slowly from deep within the moon over vast stretches of time. Others wonder whether ancient flows of half-melted ice once moved through those valleys like slow rivers in the cold. The idea of water flowing on a world so far from the sun is strange and quiet and somehow comforting to consider. Ariel sits nearly 3 billion kilometers from the sun, and the light that reaches it is thin and faint and very old. And yet, in that thin light, the icy highlands of Ariel gleam with surprising brightness, almost like fresh snow on a still morning. The valleys below those highlands, though, hold their darkness quietly, as if keeping something just out of reach. Voyager 2 passed Ariel for only a few hours, taking what photographs it could before moving on into the outer dark. Those photographs are still, after 40 years, the only close images we have of this world and its strange quiet valleys. The resolution is imperfect, the coverage incomplete, much of Ariel remains entirely unseen, wrapped in its own unknowing. There is something restful in that incompleteness, a world that has not yet been fully named or fully understood. The valleys themselves formed long ago, in a time when Ariel was still warm enough inside to crack and shift and breathe. The crust pulled apart slowly, the way ice sometimes pulls apart on a lake in early spring, quietly and without warning. Deep below that cracked surface, warmth may have once moved upward, carrying material through narrow vents into the open valleys. Whether that warmth came from tidal forces, or radioactive decay, or something else entirely, nobody has settled the question. Ariel drifts around Uranus in less than 3 days, close enough to feel the giant planet's gravity pulling gently at its core. That gravitational pulling and flexing may have kept Ariel slightly warmer than a world so far from the sun should ever be. The dark valley floors, then, may be scars of that warmth, residue of a time when this cold world was a little more alive. But that is only one possibility among many, and none of them has been confirmed, and perhaps none ever will be. No spacecraft is currently planned to visit Uranus and its moons, and so Ariel continues its slow orbit, unhurried and patient. The valleys rest as they have always rested, dark floors beneath bright walls, in a silence that has lasted for billions of years. Far away, the blue-green shape of Uranus hangs in the sky above those valleys, enormous and unhurried and very still. And somewhere in those long, quiet valleys, the dark material simply rests, holding whatever it knows very close and very gently. The question of what it is will keep, unhurried, for as long as anyone cares to wonder about a small bright moon drifting quietly through the outer dark. A slow, cold wind drifts in from somewhere very far away, carrying with it the quiet of a world that has never known warmth. Far beyond Neptune, past the edge of the solar system's warmth, there is a small world called Pluto drifting in perpetual cold. Its surface is covered in frozen nitrogen, smooth and pale, stretching across vast plains like a quiet winter sea that never thaws. And scattered across that frozen sea, something gentle and strange, hills of water ice, floating slowly across the surface. They are not large, these hills, perhaps a few miles across, smooth-sided, quietly drifting the way icebergs drift on a polar sea. Scientists believe the hills are made of water ice, which is less dense than the nitrogen surrounding them, and so they float. It is a simple, quiet truth, that on Pluto, water ice floats on nitrogen ice the way a wooden boat floats on water. And yet something about this image lingers, a frozen world where hills move, slowly, over centuries, without a sound. The nitrogen ice itself is not still, it flows, very slowly, driven by the faint warmth of a sun that is barely more than a bright star. Beneath the surface, heat from Pluto's rocky interior rises in gentle columns, making the nitrogen ice turn over like a very slow, very cold soup. The hills are carried by this slow turning, nudged and guided across the plain over thousands of years. Many of them seem to gather near the edges of Sputnik Planitia, the great heart-shaped plain that marks Pluto's frozen face. There, where the plain meets the rougher highlands, the hills accumulate, gathering slowly like driftwood at a shore. Some cluster in small groups, touching gently, their rounded sides pressed together after long journeys across the plain. How long it took them to arrive there, no one can say. Time on Pluto moves in a rhythm too slow for any human measure. Pluto takes 248 years to orbit the Sun once, a single year longer than recorded human history. Against that scale, the drift of a hill across a frozen plain feels like breathing, slow, steady, almost imperceptible. When the New Horizons spacecraft flew past in July of 2015, it captured these hills in sharp, quiet detail. It passed Pluto in a single day, moving too fast to slow down, seeing everything and staying nowhere. The images came back slowly, over many months, each one a quiet revelation from a world no human eye had seen clearly before. And among those images, the floating hills, gentle, unhurried, scattered across nitrogen ice like something left behind. No one had predicted them quite like this, individual hills, drifting freely, shaped by forces no spacecraft had ever witnessed. The hills themselves are ancient, remnants of a time when Pluto's surface was different, shaped differently by collision or freezing. Some scientists think they were once part of the highland terrain that surrounds the plain, broken off and carried in. Others remain uncertain, noting that the hills tell a story whose beginning is somewhere too deep in time to see clearly. What is certain is this: on a small, cold world far from the sun, hills of ice move quietly through a sea of frozen nitrogen. They have been drifting, perhaps, for millions of years, in silence, in cold, in the faint light of a very distant sun. There is something restful in that image, if you let it settle, a world where nothing hurries, where everything simply continues. The nitrogen ice plain has a name, Sputnik Planitia, and it holds within it a kind of patient, frozen grace. Beneath the ice, deep within Pluto's interior, there may be a layer of liquid water, an ocean, cold and hidden, never seen. The hills float on nitrogen above, and below, perhaps, an ocean moves in the very deep, beneath miles of ice. We cannot know for certain, no probe has landed, no instrument has touched the surface, no one has stood there to listen. And so Pluto keeps its quiet, its hills drifting, its nitrogen sea turning, its deep interior unknown. Far away and unhurried, those hills continue their long slow journey across a frozen world, as they have always done. And the wind, if there is one on Pluto, moves very faintly above the plain, carrying nothing, disturbing nothing, settling into stillness. From far above the turning world, the mind drifts slowly outward, past the blue rim of the atmosphere, into the cold quiet beyond. Out here, far past the familiar planets, the sunlight falls thin and pale, and the distances between things grow very wide indeed. Somewhere in that distant cold, a small body moves slowly along an ancient path between Saturn and Uranus. It is called Chiron, and for a long time it was thought to be simply a dark, quiet rock tumbling through the void. Discovered in 1977, it was the first of its kind to be found this far from the Sun, and it was alone. For years, Chiron sat quietly in the catalogues, a number, an orbit, a small cold point of reflected light. Then, in 1988, something changed that nobody had expected and nobody could entirely explain. Chiron began to brighten, very slightly, in a way that a cold inert rock simply should not do. Around it, instruments began to detect something soft and diffuse, a faint haze that clung to its surface like breath on a winter morning. This haze is called a coma, the same word used for the glowing atmosphere that forms around a comet as it warms near the sun. But Chiron was not near the sun, not even close, and the sunlight reaching it was far too faint to warm ordinary ice. Something inside Chiron was releasing itself, slowly and quietly, into the space around it. Astronomers watched through their instruments, and the coma seemed to breathe, growing brighter at times, then fading again. There were hints of carbon monoxide, perhaps, or carbon dioxide, rising from somewhere beneath its ancient frozen crust. The crust itself may hold ices laid down before the planets formed, unchanged across billions of quiet years. And yet some process still not fully understood, was stirring those ancient ices now. Chiron's orbit takes it on a long slow path, closer to the sun for a time, then drawing far away again over decades. As it draws a little closer, the faint warmth may be enough to coax those buried gases gently upward. But the timing of the outbursts did not always match the warmth, and sometimes the coma appeared when no warming could explain it. There were sudden brightenings, sharp and brief, as if something shifted deep inside the body without any outer cause. One idea is that Chiron may be slowly crystallizing inside, ancient amorphous ice rearranging itself, releasing heat as it does. This transformation, from one form of ice to another, can release enough energy to push trapped gases through cracks above. It is a quiet kind of geology, unfolding over millennia, invisible to any eye, felt only in the slow drift of gas into space. Chiron also has rings, faint rings of material circling it, discovered only decades after Chiron itself was found. The rings lie close to its surface, thin and pale, and their origin is as uncertain as everything else about this small world. Some believe material from the outgassing drifted outward and settled into those quiet rings over time. Others think an old impact scattered debris that never fell back, and there it remains, slowly circling in the cold. The truth, as with so much about Chiron, drifts just out of reach, obscured by distance and by time. Chiron belongs to a family called centaurs, bodies that orbit between the giant planets, neither quite asteroid nor quite comet. Chiron was the first and remains among the most studied, and yet it continues to behave in ways that resist easy answers. Its coma fades sometimes for years, and then quietly returns, as if on some internal schedule known only to itself. Far from any warmth, far from any eye most nights, it continues its slow work in the outer dark. And somewhere in the faint haze around it, in the thin veil of gas rising from its ancient interior, a question hangs unanswered. The little world drifts on, releasing itself slowly into the cold, and whatever it is releasing, it keeps its own quiet counsel.